Yeah, I'm actually talking about flying tokens today. I'm talking about tokens doing a spacewalk from one blockchain to another blockchain. I'm talking about bridges. So Spacewalk is a generalized bridge concept for Polkadot, and it's a bridge concept that is decentralized, that is censorship resistant, and that is trust minimized. And all these three aspects are very important to us. We see that there are a lot of bridges out there that don't have those aspects, and they're very prone to attacks, and unfortunately there were also a lot of attacks on bridges lately. Hi, I'm Torsten. I'm the CTO of Pendulum, and Pendulum is the project behind Spacewalk. But let me first talk about Pendulum. Pendulum is a parachain project. We're not live yet on Kusama, neither are we live on Polkadot, but we will be later this year. However, we are part of the chain, we are part of the Substrate Builders program in the chain track. Our testnet is live, and our chain is heavy in development. Our mission is to connect fiat networks to the DeFi ecosystem. What that means is that we want to become the central hub for fiat tokens and stablecoins. Or to be more precise or more specific, we want to tailor our blockchain for Forex. We built the perfect Forex ecosystem for debt developers. And another aspect of our chain is that we tailor our chain for business applications. So if you are a business and have business needs, for example, compliance, Pendulum will be the perfect chain to build your application on. One great example would be cross-border payments from business to business, B2B. Another aspect of Pendulum is that we integrate with local banking networks. And I want to show you this on an example. So this is the example of a cross-border payment. And as you can see, there's Pendulum in the middle. And as I already said, Pendulum is tailored for Forex. So there is a Forex AMM, or actually an ecosystem of Forex AMM. Everyone is invited to build their own AMM for Forex in our system. And a Forex AMM would be an AMM that has curves that are optimized for Forex, or it allows for single-sided liquidity pools. Now, if you look at a cross-border payment from one region A to a region B using Pendulum, then you would use those local banking integrations in region A and region B, which we achieved through banks or fintechs in those countries. So if you want to move a fiat coin from region A to region B, you would first tokenize it with a local fintech or bank in region A, would then use the Forex AMM to exchange it into a fiat token of region B, and would then detokenize it with an off-ramp that is built into Pendulum. Those local banking integrations obviously are important for Pendulum, but Pendulum also focuses on connecting to all the other blockchain ecosystems that have a great supply of stablecoins, be it Terra, be it Stellar, or other blockchains. So we are going to connect to all the blockchains through bridges that have a great supply of stablecoins. And through those bridges, we bring in those stablecoins into the Polkadot ecosystem, so that also all the other parachains can benefit from them. Because obviously, Pendulum, being a part of Polkadot, or will be a part of Polkadot, will be also connected to those other chains. Now, since we are going to build those bridges, or already building those bridges, we looked at a lot of different bridge concepts and a lot of different blockchains, and different blockchains require different approaches for bridges. And it's actually quite complicated. So we intend to unify this, and that's what Spacewalk is about. Spacewalk is a unified approach to building bridges. It's a bridge standard for .sama. Or to be more technical, it's a bridge standard for Substrate. And it's not just a standard, it's actually also a specific bridge implementation. Although we are going to use Spacewalk in Pendulum, Spacewalk itself is independent of Pendulum. It's an independent project, it's its own repository that has no reference to Pendulum itself, and it can be used by any other substrate chain. So it boils down to a palette that you can plug into your own substrate chain if you want to use Spacewalk. And it also has a couple of clients and services that you need to run in addition to this, depending on the bridge or the network that you want to bridge into. Those services can be oracles, it can be custodians that you need to operate next to your blockchain. I want to stress again that Spacewalk is decentralized. It's a decentralized concept. We looked at many different bridges, and unfortunately, a lot of bridges are not really decentralized. They're either totally centralized or they claim to be decentralized without being decentralized. And it turns out that this centralization is prone to attacks, and we have been observing a lot of attacks lately. Those attacks can be due to bugs. That also happens, like for the wormhole bridge, but most often those attacks happen because those bridges are not really secure or decentralized. We also want to, Spacewalk is also trust minimized. That means that even if you have human actors, for example custodians, then those custodians are economically incentivized not to misbehave. And if they misbehave, you're guaranteed to get your money back. Furthermore, Spacewalk is censorship resistant. That means if you need to interact with human actors, like custodians, they could deny service to you. But you're always able to go to another custodian or another actor, or you can become your own actor in that decentralized network, so that at the end you're always guaranteed to get service in Spacewalk. Now let me show you how it looks like if you want to plug in Spacewalk into your own chain. Spacewalk itself is a standardized API and has standardized components. So if you use Spacewalk, you can use different components like puzzle pieces that you plug into Spacewalk that you can use for the different bridges, but for your own substrate chain, it looks very standardized. So, for example, Terra or Stella or Solana would be these pieces. And this when it comes to this standardization or this unification, let me particularly talk about unified mappings. When I talk about mappings, I talk about certain aspects that you find in one blockchain that you need to represent in another blockchain, and you need to map them. And that, for instance, could be assets. You need to always map an asset from one blockchain if you want to bridge it over to your blockchain. You need to map it to the space of assets that you have in your blockchain. For example, assets in Bitcoin, you have Bitcoin. In Ethereum, you have ERC20 tokens. In Substrate, you probably use a palette for multiple currencies. And so assets look very different in different blockchains, and you need to map that somehow. And Spacewalk unifies that. Another aspect is balances. That's very simple, but you need to represent balances somehow. Sometimes you use 64-bit numbers, sometimes 128-bit numbers, and so on. You represent units differently, and also that needs to be mapped. And Spacewalk unifies that. Thirdly, you need to always map addresses. That's a big hassle. If you use the EVM palette in your substrate chain, you will have two different address spaces. One that you typically use in Substrate and one that you have in Ethereum-like addresses. Moonbeam has a different approach. They use unified address space. That means that every address they have is an Ethereum-like address. And when you have a Substrate chain, you're always free to configure the addresses in the way you like them. But if you bridge to at least two different blockchains, that would already require you to at least represent two different address spaces. And also Spacewalk will unify that. If we talk about addresses, we also need to talk about key pairs. If you are an account owner, you have a key pair that you use to sign transactions for your account. And the public key of that key pair is usually used to derive the address of your account. And also those key pairs need to be mapped, because key pairs and signature schemes usually look very different in different blockchains. Now let's have some fun. Let's look at a concrete example. I talked about Spacewalk in a very general way, but let's look at one concrete Spacewalk instance, namely the Spacewalk instance for Stellar. And I want to point out why it's interesting or why it's important for us to bridge to Stellar. Namely, I said that we are interested in stablecoins. And Stellar has a great support and supply of stablecoins. Stellar invested heavily into working together with local banks and banking networks to provide fiat-backed on-ramp and off-ramps for stablecoins. And so far, they have more than 15 of these stablecoins in many different countries. For example, tokens for Brazilian reais or for Nigerian naira. And I particularly want to talk about Stellar today because bridging to Stellar is actually quite hard. It's quite complicated and not so easy. And that's for different reasons. First off, Stellar doesn't support smart contracts. And if you want to bridge to a chain that supports smart contracts, that's still complicated, but it can be usually done in a trust-free way. Because if you can encode the logic of your bridge in a smart contract, then everyone can study how that smart contract works. Everyone can assess that the smart contract works as expected, and so you know that you can trust that smart contract, and you know that you can trust the bridge. If, however, you don't have smart contracts, you will need to deal with human actors. For example, you need to deal with account holders that are custodians for your assets. I will show this on the next couple of slides. And that means that you somehow need to mitigate that those human actors can behave in a way that is unintended and not as expected or as specified. So for example, they could run away with your money. Another big problem is that Stellar does not allow for usual chain relays that you would usually have for bridges to proof of concept, to proof of work chains. If you have a proof of work chain, for example, if you want to bridge to Ethereum, then you would have something called a chain relay, and that chain relay helps your own bridge to really understand what happens in the other chain in a trust-free way. And such a chain relay is based on two different aspects when we talk about proof of concept works, proof of work chains. The first one would be that a proof of work chain has Nakamoto consensus. That means that if you look at all the blocks that exist in the network, or actually only at the block headers, then you can arrange those block headers in a sequence, and you will observe that it's actually not just a sequence, but those block headers, they branch out, but you're always able to tell what is the currently valid subsequence, or the currently valid chain, by just looking at the block weight. You take the block with the highest weight, and you know that's the currently valid block, or the sequence of currently valid blocks. So if your chain relay only knows the block headers, it's still able to identify what blocks are the valid ones. It still doesn't know what are transactions in that block if it just stores the block headers, but that's where you have something called simple payment verification and proofs, transaction proofs. So although the chain relay doesn't know what's inside the block, anyone can come to the chain relay, provide a transaction, and prove to the chain relay that the transaction is actually inside that block. And that works with something called a Merkle proof, and the Merkle proof is based on the fact that transactions inside a block are arranged in a tree, a Merkle tree, and when you want to prove that your transaction is in that tree, you just need to provide all the nodes on the path of that tree from your transaction to the root. And this is much shorter than providing the complete set of transactions. It's very efficient. It's actually logarithmically smaller. So if you have 1,000 transactions in your block, your proof is only contains 10 nodes. So it's very small, very efficient, and that's very important for bridges. You want efficient bridges. You want scalability. And Merkle trees and Merkle proofs allow for that. In Stellar, however, you don't have Merkle trees. Merkle tree in Stellar, the transactions inside a block are not arranged in a tree. For that reason, you don't have this efficient way to prove that your transaction is inside a block, and for that reason, you don't have a typical chain relay. So we had to work around that. Before I talk about how our workaround looks like, let's first talk about the general aspect about how bridging works with Stellar. And I use terms here, issue and redeem, that I took from InterBTC, from the InterBTC bridge. So the first one, of course, is issuing a node, a token. Someone in Stellar wants to send a token to the substrate chain that uses the Spacewalk palette, and they would first send the token inside Stellar to an account. It's a specific account that is used to lock that token. At the same time, the Spacewalk palette would mint a similar token, a map token, inside the substrate chain and send it to the user account in the substrate chain. So what we actually have here is a wrap token, which is backed by the original token on Stellar. As long as the token is really locked in that account, that works pretty well. The opposite operation is to send back that token. So let's say the user wants to unwrap that token and send it back to Stellar. They would first use the Spacewalk palette to burn a token or burn a couple of tokens on the substrate chain, and at the same time, the token would be unlocked from the lock-in account and sent back to the user. This scheme works pretty well as long as we can guarantee that tokens are really locked in those accounts. And here, we need to now observe that the locking account cannot be controlled by a smart contract. As I already pointed out, Stellar is not smart contract capable, but it needs to be controlled by human actors. And that's a big problem. If you only have one human actor, one single person controlling the locking account, you really need to trust that person. And in order to distribute that trust, what you would usually do is to introduce a decentralized authority. That means that you use multiple signers of that account. Not just one signer, but many, and you can distribute that trust. And Stellar is very good for this, because Stellar has a built-in feature for multi-signature account. For example, n out of m multi-signatures. That means you have m signers, and n of them need to sign a transaction. And so if you have at least n people in that network that you can trust, then you can also accept that the rest of the actors that own that account or that are signatures of that account cannot be trusted. Still, that concept is not really secure and not really decentralized. And in Stellar, the main limitation is that you only have 20 signers. And if you have only 20 signers, I don't think that this is truly decentralized. True decentralization means that you have that everyone can always come into this decentralized network and also become a signer themselves. If there are already 20 signers, you cannot join anymore. And it's also really hard to coordinate co-signing in that network. You need to have your own protocol to send transactions around, signatures around, collect them, and then send them to Stellar. And it's also really hard if you want to change your set of signers. You now need to register new co-signers and so on. So you need your own extra protocols to arrange for all of that. But something that's even more important is that this scheme is prone to Sybil attacks. It could always be that a single attacker takes over some of those co-signers, or actually a majority of co-signers, and is able to sign a transaction to unlock tokens and send them to their own account. And that just happened. Just recently, at the end of March, there was an attack on one chain, on one bridge that uses precisely this concept, and a single attacker took over 5 of 9 co-signers and was able to run away with $600 million. That's why this is definitely not a secure bridge. We need a different concept. Now let me talk about this different concept. I want to point out that this concept for our bridge is based on the inter-BTC bridge. So Alexei from Interlay already pointed out yesterday that the scheme that they devised for their inter-BTC bridge is the only truly decentralized and trust-minimized scheme for a Bitcoin bridge. And since Bitcoin doesn't allow for smart contracts and Stellar doesn't allow for smart contracts neither, also that design is the only one that we can use in order to have a decentralized and trust-minimized bridge. That's why our bridge is based on inter-BTC, or the Stellar bridge. So in order to understand how that works, we first talk about vaults. You already saw that locking accounts. Now you see that there is not a single locking account anymore, but there is a multitude of locking accounts, and they're called vaults. Everyone can create their own vault. Everyone can come in, and whenever you want to issue tokens and send them from Stellar to the substrate chain, you can just select any of those vaults and send the tokens there and lock them there. So what we achieve is decentralization not through multiple signers of a single locking account, but by just introducing multiple locking accounts. And this is a truly permissionless system, as everyone can create their own vault and also close their own vault if they don't want to be a vault anymore, and is a highly dynamic system. The next aspect is that those vaults are, of course, still controlled by human actors. No smart contracts. So we need to incentivize those human actors to behave as expected. And this is achieved through collateralization, over-collateralization, actually. So every vault operator needs to first lock some collateral with the Spacewalk pallet. And the tokens used for that collateral could be DOT or KSM tokens, if it's on Kusama. Could also be different tokens, for example, to allow for liquid staking. And what we need to achieve is that the value of the locked tokens is 150% of the value of the collateral is 150% of the value of the locked tokens. And of course, the tokens that you use for the collateral and the tokens that are locked, they're quite different. For example, in a typical application on Polkadot, the locked tokens would, the collateral tokens would be DOT, and maybe the user wants to bridge USDC from Stellar to Substrate. For that reason, the vaults would lock USDC. Now, since there are two different currencies, you cannot guarantee that the collateral value is always at 150% of the locked values, as those prices can change, and the value of the DOT tokens can drop relative to USDC. So whenever the collateral value drops below 120%, the vault will be liquidated. And liquidation means that the collateral is now open for arbitrageurs to come in to exchange the collateral tokens for the locked tokens and give them back to the user, so that the user at the end gets all their locked tokens back and the arbitrageurs actually get a little bit extra, so that they have an incentive to actually make that happen. So liquidation just means that at the end the user will still get their money back, although the collateral value dropped below that threshold. Liquidation will also happen if the Spacewalk palette observes that vault operators misbehaved. And in order to observe that, we need that solution that I talked about before, namely that we need something like a chain relay, but our solution is actually an oracle, and we call it the Stellar Oracle. And that Stellar Oracle is a truly decentralized oracle and a trustless mechanism to forward information from Stellar to the substrate chain and to the Spacewalk palette. And this is required in two cases. First, if the user issues tokens and locks them in a vault, then the Spacewalk palette needs to know about this. It needs to know that that happened and that the Spacewalk palette now needs to mint tokens in the substrate chain. On the other hand, if a vault operator misbehaves and takes tokens that are locked for their own purposes and sends them somewhere else, then the Spacewalk palette also needs to know about this. And this will usually happen by some watchers sending that information to the Spacewalk palette, and that will be used by the Spacewalk palette to liquidate that vault, because the vault operator misbehaved. Finally, I want to talk about how that oracle actually works, because it's very Stellar specific. And in order to understand that, we first need to understand how the Stellar network and how the Stellar consensus mechanism works. I don't want to go too deep into the details, but let me first point out that in the Stellar network, every node operator needs to express what other nodes they trust. So you express that you trust another node, and by that reason, some nodes enjoy more trust in that network than other nodes. If you take the nodes that have the highest trust in the network and put them into a group, then this group is called the Tier 1 group in the network. These are the most respected nodes. This group of nodes rarely changes, and currently it's just 23 nodes. We know a lot about those nodes because we have been operating 3 of those nodes for over 3 years already. So we are also, our company Satoshi Pay, that's behind Pendulum, also operates Tier 1 validator nodes. Now, whenever nodes in that network vote on a block, they send messages, which they use to express what they voted on. Those messages are signed. Every node has a key pair, they sign those messages, and the public keys are well known and rarely change. All that information is now encoded in the Spacewalk palette. What we encode is the Tier 1 validator network structure and the public keys of those messages. And now we make sure that every message will be forwarded to the Spacewalk chain. When I say every message, I mean the messages for the voting about blocks. And so we only need to know about what the Tier 1 validator nodes voted on in order to derive what block in the Stellar network has been finalized. And I don't want to go into more details, but there are some more interesting aspects that are important here, but everything can be encoded in the Spacewalk palette, and what's important to know is that this structure changes so rarely that we can definitely put it into the Spacewalk palette, and whenever it changes, we just use government mechanisms in order to update that information. Because whenever anything changes in the Tier 1 validator network structure, that also changes through governance mechanisms in Stellar. And we can ensure that this oracle is at least as secure as the Stellar network and as the Stellar consensus algorithm. So that's all I wanted to say about Spacewalk today, about the Spacewalk Stellar palette. Thanks a lot for your attention. We are very happy if you go to our website or follow us on Twitter or even contribute to our project or into Spacewalk. Thanks a lot.